Thanks, Jofei. This is Ke Zunyong from Advantech Shanghai, working as Solution PM. Here, please allow me on behalf of Advantech Company to warmly welcome all of you to attend this LEAP camp. Thank you everyone. My topic will focus on the energy savings for HVAC chiller plant. The Intelligent Energy Management System for HVAC system, ultra-efficiency chiller plant solution to optimize HVAC system. At first, let's have a look for current situation of HVAC industry. More than 80% traditional chiller plant control system works inefficiently. Some of them even works manually since malfunctioning or in paralysis state. 30% to 50% energy are wasted. So the efficiency of them need to be improved urgently. From the market share, we see that 60% plants do not have monitoring and control system. 35% have traditional BAS system. Only 5% have cloud-based intelligent management system. This famous efficiency classification of chiller plant comes from Lawrence Berkeley National Laboratory. The graph shows 80% of existing chiller plant work with the efficiency SCOP below 3.5. According to China GB 50189 standard, the normal efficiency of chiller plant should be between 4.1 to 4.9. For Advantech WISE-iEMS HVAC application, the SCOP can be better than 5.0. SCOP 5.0 is the high-efficiency chiller plant horizontal line. From this graph, we know that there is huge energy saving potential for chiller plant. This slide shows the load and weather profile of HVAC system. The table shows chiller plant runs at a load percent from 30% to 70% at most time, and system load change along with weather condition change. In other words, HVAC is a part load industry and depends on weather condition change. This is the base of energy efficiency optimization. Here shows the conventional chiller plant control system. For the top 3 BAS systems like Honeywell, Siemens, Johnson Control, all of them are this DDC-based system. Chiller plant is separated to 3 loops: condenser water loop, chilled water loop, and refrigerant loop. All the components are controlled in each loop without overall control. PC workstation only monitor the plant and give the set points of each loop manually. This control method called silo control. Last slide, we learned there are 2 water loops in condenser and chilled water. For the both loops, there are energy consumption conflict of plant components. For the same cooling output in condenser water loop, we can reduce condensing pressure to reduce chiller energy consumption. However, this will lead to more energy consumption for condenser water pumps and cooling tower, since low condensing pressure needs low condenser water temperature. For the same load demand in chilled water loop, we can increase chilled water differential temperature or reduce chilled water flow to reduce chilled water pump energy consumption. Thus, chiller power consumption will increase. This slide shows the typical application architecture. It has 4 levels. The base level is on-site equipment, such as chiller, pumps, cooling towers, variable speed drivers, motorized valves, power meter, sensor, etc. The second level is edge data acquisition. Advantech can provide total solutions such as edge data collector ECU module, edge controller ADAM module, and so on. The third level is cloud platform, named WISE-PaaS platform. Advantech WISE-iEMS works on this platform. WISE-iEMS is a mid-data hub with digital twin low-code platform, connecting edge layer and application layer. The upper level is HVAC application. Now let's look at the HVAC solution in details. It has 3 types application functions in summary. The basic type are real-time monitoring of equipment operations, alarm, and notification. It shows all the operation parameters of chiller plant dynamically. Also gives the alarm message and notify to owner through email, instant messenger like WeChat, WhatsApp. Advanced type are intelligent data analysis, precise diagnosis, optimization of operational strategy, and real-time system intelligent control. Such as for intelligent analysis, it can analyze the key parameter like chiller plant performance, efficiency of equipment, power consumption, etc. if they are in normal state or normal level or not. For some abnormal parameter, we will date from the reasons in different aspects, like efficiency gap, sensor failure, or sensor out of range, misalarming, etc. According to the current operation condition, applying with AI and cloud computing technology, optimize the chiller plant operating combination and the parameter. I will introduce this part in details in the following slides. The third type are value-added services, including predictive maintenance and professional evaluation and report services. For the rotary mechanical equipment, like pumps, motors, we can provide the predictive maintenance service, like equipment failure prediction, equipment efficiency degradations. This slide shows the detail of a chiller plant. Pass through the routing from system layer to equipment layer to parameter layer to completely present operating data. For example, from the overview of dashboard at the right-hand side, we can observe the key KPI of cooling plant, such as system COP, power consumption, cooling tonnage, etc. Then, let's see economic operation evaluation. System needs to evaluate whether plant is working economically or not. If not, find out the reasons through the root analysis model of multiple energy efficiency influence factors. For example, use flowchart showed in the graph to benchmark the energy efficiency of chiller plant. Analyze the upper and lower stream factors of the key energy efficiency ratio. And we also analyze equipment energy efficiency. Such as for pumps, we built the pump model to analyze pump operating efficiency if it is out of range. You know pump efficiency decays sharply when they operate at part load. Pump need to be controlled at high efficiency operation. For the significant parameter system COP, we need to benchmark the level. It has two ways. One is benchmarking with standard, such as China GB 50189, Singapore Green Mark standard. Another is comparison to pre-retrofit. This can be applied with retrofit project. Now, let's discuss the AI algorithm part. At first, we will build equipment model for chillers, pumps, cooling towers, load profile, and the system hydraulic profile. Since this solution is based on cloud platform, all the modeling units can be gradually exactly improved. This is the advantage compared to local BAS system. This slide shows the first AI optimization algorithm, best performance sequencing. For intuitive comparison, we take a look at traditional capacity-based sequencing. The plant configuration are 2 duty chillers and 1 standby. Below curve shows the chiller performance at different current percentage, or we say load percentage. We learn that the best efficiency point is about from 40% to 50%. High efficiency range is about from 30% to 70%. With the increase of load, chiller will load until to 100%, then open next chiller. The right-hand bar chart, this results in about 80% power consumption. This slide compared to conventional capacity-based methods. Advantech use best performance sequencing, short for IEMS BPS. Similarly, chiller increase the motor current percent along with zone load increase. However, chiller will stay on next one at a certain current percent point. This point would be determined with overall efficiency of chiller combination. The aim for this method is to operate chillers in high efficiency all the time. At the right-hand bar chart, the result shows about 60% power consumption. And compared to last slide, it can bring up 20% energy savings. This slide shows the second key AI optimization, improved genetic algorithm. We just mentioned the two conflicts of energy consumption in condenser loop and chilled water loop. This method can solve the conflicts perfectly. After modeling of each component, this application will calculate the minimum power consumed based on improved genetic algorithm. For HVAC system, it may easily cost partly optimized, not overall optimized. Due to the genetic algorithm characteristic and gene mutation, this problem can be perfectly solved. The advantage of this, we see build equipment model based on operating data and device type, and can upgrade the model parameter continuously generation by generation. The third key AI optimization is load forecast and demand-based control. We will build load profile model and forecast the load trend. This would be one principle of adding or subtracting units. Demand-based control method would determine the cooling tonnage production according to terminal cooling tonnage consumption. This can minimize energy waste. Now, let's summarize the key AI algorithm or IEMS HVAC solution from Advantech. The first one is best performance sequencing. The second one is improved genetic algorithm. The third one is load forecast and demand-based control. The three AI computing methods are the strong weapon from Advantech. And how to set up the HVAC energy efficiency management system quickly. We have 3 steps. First step, upload edge data to the cloud. Second step, set up asset topology and bind the data according to the data points and edge collected data. Last step is information presented in a standard dashboard. So easy process for partners. And how to establish a high efficient energy station. We also have 3 steps. First step, monitoring and analysis of current plant, finding the waste of system, then energy saving and renovation. We take some measures to improve plant operation condition, such as management of energy use behavior, adjust operating parameters, renovate existing equipment replacement, etc. And the last one is real-time intelligent control, applying with AI computing to dynamically adjust system operating strategy. This can improve chiller performance efficiency effectively. This slide shows the application sense. These solutions are mainly applied with water-cooled energy station, heat pump energy station like air-cooled chiller plant, ground source chiller plant, or water source chiller plant. The scenery can be office, factory, hospital, shopping mall, school campus, hotel, etc. How we benefit from this HVAC solution? Through IEMS HVAC solution, the system overall energy saving can be from 5% to 50%, and it improves equipment health condition as well by around 10% to 20%. Also, we see the 3-level benefit approach. The level 1, build digital twin energy station and realize intelligent energy management. Level 2, the system operates highly efficiently and realize the goal of saving 5% to 10% energy. Level 3, facilitate equipment renovation, and reach the goal of saving 20% to 50% power consumption. Now let's look at the one case for IEMS HVAC application from Tianjin, China. The performance of chiller plant is about 3.1 to 3.3 before retrofit. This is pretty low according to the performance classification from LB&L we just mentioned. Applying with IEMS HVAC optimization solution, the system COP can reach to 4.5. Energy savings is about 30%, saving 900,000 kilowatt, about Taiwan dollar 2.8 million per year. A successful application for HVAC application. Okay, finish this presentation. Thank you to all of you for listening. Hoping to help you in HVAC applications. Thanks.